Welcome to this CPC webinar. This is the first part of our CertiCAB workshop. My name is Richard Holland and I head up the Regulations, Safety and V&V team, which is part of the New Mobility Technologies Directorate here at Connected Places Catapult. For your information, this webinar is also being recorded and live streamed. I'll be joined on the panel today by my colleagues. So Zane Seigel is the overall technical lead for the project, along with Tom Webster and Rob Myers, who are each leading one of the two technical work packages. We also welcome Siddhartha from WMG in Warwick to talk about scenario-based validation methods later on. And I'm delighted that we're also joined by Duncan Kay from the UK's Department for Transport, who's shortly going to kick us off with the keynote talk. Just a few more words from me before that. There are a lot of people on the call, which is great. Thank you for joining. So today's webinar is not intended to be too interactive. There's going to be a couple of live polls that we'll ask you to participate in. Otherwise, we'll do pretty much all of the talking today, but the opportunity for the discussions will follow in the small group sessions in the second part of the workshop. At registration, you're asked to sign up to one or more of these, and I'll explain later how this is all going to work. Having said that, there will be a short Q&A session at the end to sort of clarify or elaborate on what we presented. We'll be using the Q&A function in Zoom for that, so please type your questions throughout and we'll answer as many as possible at the end. It is possible or likely that we won't have time to answer all of your questions today, but the small group sessions will be more interactive and we'll hopefully answer many of them. We'll also look to try and post some written answers to maybe some of the questions, along with some other material from today and the small group sessions, which will be done at a later date. So without further delay, I will hand over now to Duncan Kay from the UK Department for Transport. Duncan, welcome.
Thank you, Richard. I hope everyone can see me. As Richard says, I'm Duncan Kay. I'm Head of Vehicle Engineering in International Vehicle Standards Division in the Department for Transport. And it's a pleasure to be here, even if I'm speaking to you from my loft room on the south coast. So I apologize if there are interruptions from seagulls who are nesting on the roof above. We live in interesting times. A bit of background on the role of International Vehicle Standards. We are the division within the Department for Transport that negotiates type approval legislation and sets standards for new road vehicles. And a key part of that is our work in the United Nations on UNECE regulations. So it was actually at the world's first ever virtual meeting of Working Party 29, which is the working party at the UN that works to harmonize vehicle regulations. So there was a virtual meeting last month, where for the first time, the world's first UN type approval regulation on automated vehicles was agreed and adopted. And that's the UNECE Automated Lane Keeping System regulation. Alongside that, there were two other regulations which are equally important for these types of vehicles, one on cybersecurity and one on software updates. And they were all adopted last month and will be coming into force at the beginning of next year. The Automated Lane Keeping System regulation allows for vehicles to drive themselves in lane on a motorway at up to 38 miles an hour. And this is really important. This is a groundbreaking moment, I think, because for most people, this will be the first time that anyone will have any members of the public will be able to experience for themselves an automated vehicle and allow themselves to be disengaged from the driving task and undertake other activities. So that's an important first step. And we're expecting that at least two manufacturers will be launching vehicles in the first half of next year. And many others that we're speaking to have plans to launch automated products soon after. And it's important that I provide this sort of background to today's meeting. so you understand the context of the UN work and how what we're discussing today fits into the work and vision of the department. So the UN work will continue. There are already proposals to amend that regulation to allow for a greater operational design domain up to higher speeds and including lane changing. And there are multiple UN working groups set up to develop further thinking in this area on functional requirements, on validation methods for automated driving, on data storage systems for automated driving and event data recorders, and further work on cybersecurity and over-the-air software updates. But I think if I were to characterize all that very important work, it's really incremental automation. So it's basically established auto manufacturers who are involved in those working groups, and they're working to gradually develop regulation, as I say, to introduce the first, to use the SAE levels, level 3 vehicles, and it's a gradual reshaping of UN type approval regulations to be able to account for this technology and work out ways of approving it, so it can come to mass market. And the manufacturers, I think, are on a learning curve and see this as something that can be used in a very limited operational design domain to start with, tightly controlled geofenced areas perhaps, which can gradually be expanded as they grow in confidence in the technology. The vehicles themselves are, again, an incremental step from the current vehicles that are on our roads and on sale today, and they're based primarily on traditional sale and ownership models rather than more advanced concepts like mobility as a service, for example. And indeed, although there's a huge amount of work and activity in the UN, that work is not yet started on more advanced, more creative and radical designs of vehicle design, and how those could come to our roads. So the UK government sees huge potential benefits from automation, and really those benefits come when you start looking at not so much level 3 SAE level 3, but more higher levels of automation, and you see that not just in passenger transport or passenger cars, but also and shared mobility services, but also in logistics, from last mile deliveries to long haul freight, for example. And it's the higher levels of automation that really start to transform our transport system and deliver the full benefits. And the UK government set out last year the Future of Mobility Urban Strategy, set out a vision for a revolution in the transport system, emphasizing the potential of self-driving vehicles, which are at the heart of our industrial strategy. And as we exit the transition period at the end of this year, we have an opportunity to explore potential newfound freedoms in our regulatory structure. And we know that there are companies out there, many of them based in the UK, with visions for new types of vehicles, new ways of doing things, facilitated by automation, and we want to enable that. But of course, we have to ensure that these new automation systems and mobility systems are safe and secure by design. And that's why the UK government's Centre for Connected and Autonomous Vehicles announced in September last year that we've been developing the CAVPASS process, which is a new process to assure the safety and security of connected and automated vehicles. We already have one of the most open regulatory systems that has allowed public road testing of automated vehicles under our code of practice approach when they are supervised by a safety driver. But we know that companies want to go further than that and bring creative new designs to our roads and explore the possibilities that automation opens up for vehicle design and development. And so the CAVPASS process puts in place a means to allow this to happen safely. And this CertiCav project is a key part of that. And that feels like a good point at which I should hand back to the Connected Places Catapult team so they can explain a little more about who they are, what they do, and more about the CertiCav project. Thank you.
Great, thank you very much, Duncan. And pleased to say that it sounded like the seagulls were behaving themselves today, so thank you very much. Okay, so to help me introduce the project, I'll maybe first say a few words about the Catapult for those of you who do not already know us. So the first catapults in the network were set up around about 5 years ago under UKRI, what was previously known as Innovate UK. There's now a network of 9 R&D centres, which really sort of operate in the intersection between national and local governments and industry, so SMEs, OEMs, suppliers. We're here primarily to help create jobs and growth throughout the UK in a number of key sectors. So the Connected Places Catapult focusing very much on smart cities and transportation. We work closely with a number of other catapults in the network, particularly energy systems for electrification. The higher value manufacturing, we'll hear from Siddhartha later, associated with them through WMG, and a number of the others, digital as well. The mission of the Connected Places Catapult includes helping to remove some of the barriers and obstacles within the 4 grand challenges areas. So that's future of mobility, clean growth, aging society, and AI and data. This is achieved largely through collaborative R&D work, academic and SME engagement programs, and also some direct work with standards bodies, government departments, and other agencies. In terms of the vision, connected and automated vehicles are an important enabler to some of the new mobility services that will provide the connectivity and transportation solutions in future smart cities. And of course, the safety assurance of these vehicles is one of the key barriers we're helping to try and remove through this project as part of the wider CavPass initiatives. So, what's the challenge? Well, driving a vehicle can be very complicated, especially in the modern world. Now, we've all been moving around a lot less recently, but drivers maybe consider a journey you've made regularly. So perhaps your commute to work in the days we were doing that, and hopefully soon will again soon, the school run, or even just a trip to the shops. And while that may be considered fundamentally the same journey each time it's made, you may take the same route or one of just a couple of routes. It's actually unique every time that you make it, in terms of, for example, the combination of the weather and lighting, different traffic conditions, maybe some temporary roadworks have popped up, or some other random events may have occurred. The human driver is actually incredibly good at perceiving a situation or a scenario and deciding how to navigate it. Our driving skills and experience then let us control the car safely, and this all happens almost subconsciously for an experienced driver. So 99% or more of the time, humans actually make very good drivers. But of course, we make mistakes, and that's where automation helps to eliminate those mistakes, which lead to loss of control and accidents. Computers don't get tired, they don't get distracted by other devices, and they don't drink alcohol, for example. But those mistakes that we make are actually very rare, and automating the things that humans do well is incredibly difficult. So vehicles that do the driving themselves in place of a human driver are vastly more complex, as the systems on these vehicles must perceive their surroundings, predict and react to the behavior of others, and determine a safe course of action, whilst also making progress on the journey. So new approaches are needed to assure the safety of those automated driving tasks. So working as part of the wider Centre for Connected Autonomous Vehicles CavPass program, CertiCav aims to develop some solutions which help to solve some of these challenges of safety assurance for highly automated driving. Our specific goals are to develop a framework which helps inform UK safety assurance schemes that will enable the introduction of CAV services and support the evaluation of applications for advanced trials, and to help inform the DFT's thinking in the area of CAV safety. And specifically, CertiCav will propose some safety criteria to be met, as well as some assessment methods that can be used to demonstrate compliance to these. We'll then demonstrate the application of aspects of the framework using a worked example of a highly automated driving system. That will include a demonstration of our music scenario database in the wider context of safety assurance, with a population of some additional scenarios relevant to the system under test or evaluation. And then finally, we want to build upon and leverage existing expertise. So as we said, working within the wider context of CAVPAS and with consideration of the previous and current work going on through some collaboration and consultation, will encourage the knowledge transfer and overall advancement of UK skills and capability. And that's why we're all here today. So how are we going to achieve this? Well, as well as a formal project team and steering panel to provide the governance, we will have a continuous and regular stakeholder discussions and consultation. We have the all-important advisory group, which includes experts from a cross-section of industry, so developers, OEMs and suppliers, research and academic institutions, other NGOs, standards bodies, and of course, the government departments, many of whom are on this webinar today. We're also holding ad hoc meetings and information exchanges, providing monthly newsletter updates, and we'll seek feedback and run technical workshops such as this week's events. And then, now endless debate could be held on the topic of specification of the safety criteria, but to make any measurable progress, we have to really put a stake in the ground and make some assumptions and proposals for a starting point and to begin to develop the framework around those. So we'll show later how we've developed a set of proposed criteria from stakeholder input taken during the previous phases as part of the music project. Evidence and assessment methods. What tools and techniques will be required to generate data and evidence to show that the safety criteria are met? And of course, authoring the document itself towards the end of the project. Development of relevant standards underpins all of this, and we continue to actively participate in as many of those as we can. And finally, as mentioned previously, we plan to physically demonstrate the application of aspects of the framework, so long, of course, as social distancing and other coronavirus-related restrictions allow us to safely do so. So a very quick recap on some of the terminology we'll be using before I conclude. ADS is hopefully a term you're all quite familiar with, whereas ADSE is perhaps new to some of you, and we'll be using this term throughout the talks today. CAV, hopefully, again, very familiar, but important to note, as Duncan alluded to earlier, we're only really interested in automation levels 4 and 5 as part of CertiCAV. The DDT, dynamic driving task, is fairly self-explanatory, although again, a note, this refers to the tactical driving decisions and actions rather than a strategic journey planning type activities. The EGO vehicle is a vehicle or system which is under test. And again, the ODD is a fairly common term and well known. So that concludes my introduction. I'll now hand over to Rob, who's going to take us through the next section.
Hello, yes. So as Richard's hinted at, the CertiCAV project is relatively new, but CPC has been working in this area of CAV verification and validation for a little while. So what I'd like to do over the next 10 to 15 minutes is summarise some of the work we've done so far, particularly with respect to the music project, which ran for 2 years until March this year. So, as was mentioned a second ago, it's very familiar probably to just about everyone on here that the complexity and difficulty of the task which systems on vehicles have to do is very rapidly increasing. And that also means the tools are changing. So as electronics gets more advanced, OEMs are increasingly supplementing labs and test tracks with simulation facilities and scenario-based testing. And it raises the question, if we've got complex systems which are perhaps hard to verify completely at all, but certainly in physical tests, what are the new tools and processes which regulators are going to need? This is the sort of question we started on, particularly with respect to the tool side of things, when we were thinking about the music project. So what I'd like to do is briefly introduce the music project, what it does and what the outputs were. Talk about the idea that safety is partly a compatibility problem when it comes to driving. And then, as was mentioned a minute ago, talk you through what we've done so far and the questions still to be answered on safety criteria. So, music was an attempt to start filling in that green question mark box on the slide I showed a second ago to provide a tool which could be used as part of a regulatory process for scenario verification and validation. This slide reflects our thinking about 2 years ago, when we were asking ourselves the question of what is a regulatory use case for scenario-based testing? And while the shape of this is still very much in scope and up for debate in CertiCav, there's a few features which I think are worth drawing your attention to. One of them is the idea that a regulator probably wants to have some sort of a role in defining and specifying scenarios. They might want to curate a set of scenarios and require an OEM to test against them, for example. And that implies a need for some sort of tool to assist them with this process, which was exactly what music set out to do. From this tool, we anticipated that the regulator would want to export some scenarios, that the scenarios would be tested through a combination of the OEM and independent technical services. And when combined with other evidence, which we didn't dwell on too much at that point, would provide enough confidence for an approval authority to be able to issue a vehicle certification. The other thing I think it's worth mentioning on this slide is that it's quite helpful to show the difference between CertiCav and music here. Music is about the tool, and the inputs and outputs were really to inform the design of the tool and how it would be used. CertiCav is focusing more on, for certain aspects of the approval task, how you get the overall confidence out of the evidence from both this and other techniques. So to give you a little bit of a flavour for what music does technically, here is a little diagram which sort of shows the immediate inputs and outputs. Music is the bit represented by this dash box here. Its main input is scenarios generated using external tools. And with those scenarios, it provides functionality to help manage them, by which I mean curate, store, and search for appropriate ones for the test you want to do, and also to export them for use in external tools. There's also an add-on feature where we provided the option that an interested party could choose to synchronize a private database to the master one, controlled by perhaps a regulator. And the other thing I'd like to stress about music is just how important open standards are to this process, because we're using external tools both to generate the scenarios and to test them. And this process needs to involve at least 2 or 3 and possibly many more organisations, depending on exactly how it's implemented. So scenario-based testing in a regulatory context is very dependent on open standards, and we've been pleased to be involved in some of the work which has been going on in this area, particularly around ASAM, Open Drive and Open Scenario. So that's the main output from music, which is a core overview of the product itself. That's available for download on our website, and there's also a trial system which you can have a play with. We'll be releasing an overview paper later in the year, and also a couple of other documents have been produced. One of the areas which has been mentioned already is very important to the verification and validation task is this area of ODDs and how you define an ODD in a way which is meaningful for an automated vehicle. I know Siddhartha's got more to say about that later, so I won't go into detail here. The other one, which is perhaps more immediately of relevance to CertiCav, is the pass-fail concept. So music, as part a scenario in a database is one thing, but it's only really useful if it can also be tested against. And that means you have to have some kind of method to define what good behavior looks like in that scenario. As part of music, we made a start on this process. It raised lots of interesting questions. I think we did make some progress. And I'd like to share a little bit of our early thoughts with you now. The first one, and I think one of the things which makes this quite an interesting problem, is that safety for an automated vehicle can't be defined in isolation because it depends on what other road users are doing. And I've got a silly example here to try and illustrate that. Here I've got two vehicles, and the way they're both driving along the road is perfectly safe, provided that no one else is on that road. The problem is compatibility. One vehicle is making a decision which is incompatible with a decision that another vehicle has made. Now, obviously this is a bit of a silly example, and I'm sure everyone here knows what side of a road they should drive on. But that's only because it's been defined by a rule and a regulation. And the rules and regulations which govern human driving today aren't so comprehensive that they cover every possible case. There are cases much more subtle than this, where it's not immediately obvious exactly how the compatibility between two vehicles could be managed. One question I'd like to raise and just to put in the back of your mind is, how do we handle a situation where two automated vehicles crash into each other because their developers had a different interpretation of the rules of the road? So, bringing you up to speed on the concrete outputs we had so far, these were the initial 5 criteria which we proposed as part of the music paper and have also shared with the Industrial Advisory Group. I don't want to dwell on them too much today because there's some refinement work in progress, which Tom's going to talk about in a minute. But there are a few bits which I think are worth pointing out. The first is that we've tried to cover the case of interactions in a world where we're mixing both automated and human drivers. So we've got this never cause a collision test, which implies a certain amount of rules and that there is a definition of what it means to cause a collision. There's also, that works great for robots if you can define such a set of rules, but there's also a need to handle things like human error and the interactions with other road users. So, as I say, I won't dwell on this now, but our early thoughts were that some sort of mixture of rules and more generic, more flexible measures would be needed to handle situations which came up. When we proposed these to our advisory group, the feedback was helpful and interesting. I think it's fair to say that the majority of people agreed we were on the right sort of lines, but there were a lot of interesting questions raised, particularly about how you make these measurable and applicable. And that question of making these measurable and useful effectively is one which we've been looking at over the last few weeks. And I think that brings me about to the point where it's time to hand over to Tom Webster, who'll explain a little bit more about what we've been doing in that area.
Sorry about the delay there, just getting myself displayed on screen. So hello everybody, thanks Rob. I'm Tom Webster, and so yes, I'm here to talk to you today about some work we've been doing with regard to safety criteria in the CertiCAV proposal. So just to put this into context, so CertiCAV, we're developing an assurance framework. The scope of that assurance framework is to cover the perception and tactical decision making of an automated driving system. when it's performing normatively. So we are intending to cover a range of environmental conditions that are appropriate for the operational design domain that those vehicles are operating in, and so on and so forth. And there may be that there's some aspect of checking for absence of software errors, but what we're not intending on covering is functional safety, cybersecurity, operational through life issues, and so forth. So we have the safety criteria, and well, the reason we're using safety criteria is those then relate to the system verification and validation that an ADS developer would be going through to ensure that their system is safe. And that also refers to how this system is going to be licensed and certified as safe for use on the roads, and it also relates to the deployment. And so today we're kind of focusing on that licensing aspect. How does the safety criteria relate to that? So looking at how that relates to the licensing, so we have safety criteria, a list of criteria to be met in order for the system to be qualified as sufficiently safe. That puts some structure, helps set the objective for how you go about what your methodology is for assessing that. And then you require evidence to be generated to undertake those assessment methods and make evaluation decisions to determine whether the safety criteria are met or not. So the safety criteria has a top-down effect on how your assurance framework is defined. But in developing that, there's then a bottom-up feedback cycle in terms of there are challenges and constraints in doing those assessment methods and evidence evaluation exercises. And so this is what is looking at in terms of a bit of a what matters analysis in terms of what constraints are there in terms of assessment methods and evidence evaluation, and what feedback does that have on safety criteria. So the kind of challenges that are often talked about in relation to this are what is the role of rules and risk in terms of risk evaluations? Are the evaluation specifications, are they based on common frameworks that are defined and are common to all platforms? Or do they relate to, are they proprietary? Do they relate to what the ADS developers done themselves? Another question is, to what fidelity do assessments need to be made in order to be in order to have useful outcomes? So just to highlight this, an example, a vehicle approaching a stop line, it's on green, it turns amber. So the rule is stop at the stop line unless you're so close that you cannot do so safely. And at the moment, yeah, no problem. You can stop before that stop line with no problem. But various factors can affect this. So what if there's someone who's accelerating up behind you very close, doesn't appear to have any intention of slowing down? This introduces the risk that if you do start to deaccelerate for that stop line, that you could be involved in the collision. So that changes what's going on there in terms of what's reasonable in terms of interpretation of the rules. So the kind of challenges that there always are in relation to evaluating what's reasonable, what's safe. Things like, what is a reasonable interpretation of traffic rules? Because they quite often have kind of what ifs. What is a reasonable balance between following a rule because that's what you're supposed to do and risk minimization? And there is also the kind of tricky compromise of there is always a bit of a risk appetite. People will make decisions to erode safety to a small extent if it's going to have a big impact in terms of their journey or movement of traffic and so forth. So in relation to this rules and risk landscape, we had the idea of, well, you can actually map and visualize this. So if you create an axis where on your x-axis, if on the positive side, it's referring to common specifications, and on the left side is proprietary on the negative. So the reason this is all in grey is that that is not something that's viewed from the outside. And then on the y-axis, if your positive is following rules, and on the negative is based on risk, then you can start to look at map out how driving is executed on that basis. And something else we can do here, so if you make the magnitude of the x-axis kind of quantity in terms of number of instructions, you could make the y-axis level of control. So start to map out in terms of, we put 4 arbitrary values for that. So at the high level, you've got principles going up from informative, directive, and actuation at the top. So in the act of driving, you need to be doing something at the top here to actually actuate driving instructions. But then there's some substance below that that's helping to inform set the structure as to how influencing how those actuations happen. So subjectively, human driving might look a bit like this. There's all the fabric of the road traffic rules, which is, of course, common specification, it's public, and it's largely based on rules. But it does, in the highway code, it is setting some high-level specification on how you actually go about managing risk. But these do have some detailed instructions, but they usually have caveats. So unless it is seen by the driver is safe to do so. So in the actual act of driving, drivers are individually determining what are reasonable decisions through real-time risk assessments as they're driving. So they're basing this on some common principles that are defined, but it's largely self-linked process. Something else that should be noted is that there are sort of proprietary and unofficial social conventions in place in the real world as well. So to give some examples, so Rule 144, an excerpt from that is do not drive without reasonable consideration for other road users. That's a principle. Going up the scale, only flash your headlights to let other road users know that you are there. If you then go on the other side and look at proprietary, it's generally understood. You flash your headlights to indicate you're giving away, which kind of conflicts with that. Going up to a more directive rule, you must obey all traffic light signals. That there's an example in the highway code is for how to informing how you go about risk. There's things on adapting your driving. But in reality, when people are actually executing their driving, they're making all these real-time decisions, and then these are actually governed by these actuation, low-level risk modeling that's going on inside someone's head and that they've developed and learned over time. So how this then translates in terms of testing. So when a human driver is tested, their comprehension of the highway code is spot checked with a theory test and so forth. And then in the driving test and the hazard perception test, the ability to execute their risk assessments is assessed. One observation, Do humans have an inbuilt defeat device like VW and Mercedes? Because they're probably not going to perform the same way during tests that they do as soon as they pass their test. This is a very limited sample of overall driving. This works because humans have a kind of common specification, and it's been proven over time that this works. And it's generally accepted that as a human, you continue to develop and learn after passing the test. But you can't necessarily take this, you can't take this and then apply it to an automated system, which we do not know the history, the common specification that applies to all, so on and so forth. So if we take a simple automated system, and perhaps I should have used the lane keep assist, but adaptive cruise control, quite simple. There's a specification, nice and simple. But behind that specification, in terms of how that's been implemented, there is a proprietary solution. And that proprietary solution could be implemented based on risk modeling, or it could be implemented based on implementing a fine-grained specific instructions, and most likely a combination of. And you don't know which or the other. All that's happening with adaptive cruise control is that it's passing the test. Growing that up to high-level automated driving systems. There are proposals in UNECE setting principles there. These then reference road traffic regulations, so then that references in the existing fabric there. And again, when it's actually implemented, those proprietary systems could involve either risk models or rules models. So the kind of challenges involved here are that the one thing is just relating to what's in red, saying to ensure compliance with road traffic regulations. You know, it's a valid principle, but some care does need to be taken that complying with driving rules doesn't forbid manoeuvring to prevent harm. The existing traffic regulations are referenced, but those have been developed over time as a suitable tool for managing humans, aren't necessarily applicable for automated driving systems. And they don't facilitate directly making pass-fail decisions at a scenario level. So in terms of what options are there for generating evidence for informing evaluation decisions for ADS, the principles are there and they can be applied, but they have limited fidelity or they're not objective. So if it's an objective principle, such as don't cause a collision, then the fidelity is limited, because if you're just looking at causation of collisions, you need to look at a very large number of scenarios to get a statistically valid result. Whereas if it's a more subjective principle, such as drive with due care and consideration, then your evaluation against that is somewhat subjective. You can evaluate, that it is possible to evaluate against the informative directive road traffic rules. This does require some digitalization, so to speak, of those road traffic rules. And this may be of some use. However, because those rules are relating back to reasonableness, there are limitations on what you can achieve there. If you want to grow that up and make those very fine-grained decisions, now you would need to be making a kind of what some people might refer to as a full digital highway code, and really to create something that's definitive that you can apply to all deployments is, we suggest, impractical. Likewise, you could evaluate based on risk by developing common risk models. But this again, to do these at a lower level may be possible, but to do it at a high level, to again make those fine-grained decisions is very challenging. One other observation here is that detailed evaluation requires detailed data. And this may quite often come down to things relating to driving, such as interactions between human to human, interpreting poses and gestures. And this is something that's impractical to standardize, because different ADS are going to use, detect different things, use different perceptions to inform their decisions. And so there's a problem in standardizing that. Looking at the other side on the proprietary, so it's possible to evaluate based on principles. So this is similar to the common principles. When it then comes to making evaluations based on proprietary specifications, you get the challenge with IP. And so this is something which an ADS developer has put a tremendous amount of their value into. So sharing that raises sensitivities. It allows you to make evaluation decisions based on scenarios, based on their own specifications. But what it doesn't help you do is to then actually come up with an overall validation of safety, because you've only checked that, okay, yes, it performs as per their specification, but does their specification actually provide an overall statistically safe system? And another challenge you have is that there would be use in this in terms of you can find holes in their specification, but to systematically evaluate this is going to require a very high level of effort. And this is, referencing things like the MAX 737 issue. If you've got all the lines of code, one thing, but actually evaluating that systematically and finding all the issues when you've got millions of lines of code is easier said than done. Another way of tackling this could be to have the evaluation of risk that the system is generating being shared. And this may allow you to do some verification by comparing to outcome, and it resolves how, as an evaluator, you can weigh up justify what decision is being made. However, you would still, that verification by comparing the calculation to the outcome would still need to be done over a large number of samples to get something of statistical relevance. And by doing so, what you're doing is you're forcing the ADS developer to implement risk modeling rather than doing it based on instructions that they might naturally do, and also to share this, which could be sensitive. So based on that sort of very quick analysis, this is an indicative table of how many challenges there are in terms of getting specifications to make evaluations. So principles, it's expected that there are going to be common principles, and that's useful. However, as discussed previously, the fidelity that you can evaluate based on that does have its limitations. It would be very nice to have these very low-level frameworks so that you can really do a very fine-grained assessment. You effectively would be required to develop that as a common thing, and you're then going through the same level of effort as developing an ADS publicly, which is impractical. So what you're then left with is that, yes, it may be possible to do these mid-level evaluations. So based on the existing fabric of informative, directive, traffic rules, those can be interpreted and applied to make mid-level decisions. this can be supported by creating risk models, but we suggest that this does perhaps become more challenging when it comes down to more directive risk models, because again, you're having to do quite a lot of work. So what this then translates to in terms of what options remain available for doing assessment methodologies is we think these are then the four main options left available. So number one, you can do random sampling with statistical evaluation. So you're not having to make fine-grained evaluation decisions. You're looking at things like collision severity. So easy to undergo your evaluations for a scenario, but you need a very large volume of scenarios to get a statistically significant outcome. And also you need to be careful that the scenarios you've done are true and representative of real life, which is another challenge. Second option is that you could push that to the ADS developer, say, you go and do that, and I'm just going to, you need to share me in some shape or form what all your results are. I'm going to pick a few and ask for those to be repeated for verification. So a challenge there is that based on the numbers, and most of you have probably seen the calculations before, even asking an ADS developer to actually do on that basis provide statistically relevant evidence could be considered unreasonable. And because you're just picking a few, there is still the chance of that there was some issue that's been covered up that you haven't picked. Option number three is if you pick, if you define a core rule set for, and that you can clearly evaluate, and that the behavior not defined by those rules, you now specify by reference to the scenario examples, and then this is mentioned in the music paper. What you now have is the problem that because you're defining things on a scenario basis, you're needing to have human evaluation per scenario, so it does not, you can't automate it. Your effort scales linearly with the number of scenarios. So we propose a fourth option, which is that only evaluate scenarios where it is clear cut what the ADS should be optimizing for. The issue with this is that it's only demonstrating competence for certain test conditions, and it doesn't actually provide a statistical argument for safety, but we think it's of some interest. So I don't have time to talk about all these options, but I'll very quickly talk about this last one. So what we're suggesting here is that if you look at how critical a situation is, the criticality of a given time during driving, most of the time you're not in a critical situation, there isn't high risk, and your prerogative is to reduce the chances of getting into a more critical situation. But if you do find yourself in a highly hazardous situation, then it's your prerogative to reduce the chance of that harm. So based on that principle, you could reorganize those safety criteria that came out of music and arrange them so that they fit on that scale. And then when you then pull in how the definitions are arranged, it then looks like this. So for highly critical situations, you've got hazard mitigation, where if you find yourself in that situation, you take reasonable action to avoid and mitigate collisions. And in this situation, there is when you're in a highly critical situation, there is a reasonably clear justification that it's okay to violate rules because you're trying to minimize harm by doing so. And so on and so forth. I'm running tight on time, so I won't explain all of these in detail. The very astute of you might realize that this this does help address of those challenges I presented earlier, the first two. It doesn't do so much to address the third one, which needs to involve some more things with regards to risk appetite, and that's something for another day. How this could be applied is if against the safety criteria, competency guidelines are produced that relate to factors relating to ODD and how the driving task is executed, then you can then define the boundaries that clearly fall within those safety criteria for each of those, and then have clear scenarios that you can evaluate for each of those. So for the one example, avoiding collisions, if you have the ODD and DDT racing to a low-speed shuttle, the kind of statement you might expect to see there is proportional longitudinal avoidance. So you don't need to be in you don't need to have competence for path planning, very detailed dynamic control, because you're a low-speed shuttle. But if you are a highway pilot, then you are expecting path planning. You are expecting both longitudinal and lateral avoidance because of the hazards that are present in that domain. And then you can then have proportionate scenarios defined in order to test those. So a very detailed subject. I apologize for not explaining everything in detail, but these are just some closing thoughts. So a few thoughts of the day. So care should be taken that requirements and principles applied to ADS to comply with driving rules should not forbid them from manoeuvring to prevent harm. Based on this, we do suggest there is some value in developing the interpretation of driving rules for ADS so that it provides some common structure and supports the testing framework. Structuring the safety criteria according to criticality may help resolve the independent assessment challenges accounting for risk-weighted decisions. And each of those assessment methods in that table does have its shortcomings. By applying several of them, perhaps you can cover your gaps. So that brings me to the end of my presentation, and I now hand over to Zane for the first poll of the day.
Yes. Okay. Good afternoon, everyone. So we have the first poll is about what we believe is needed from ADS safety criteria. And really, we want to both get a snapshot of what is the views of the range of stakeholders we have with us today. And we also want to focus people's minds so that we can have some interesting discussions on the post-webinar meetings that will be happening later this week and next week in smaller groups. So the questions which you should see coming up on your screens now really is talking about some of the fundamental issues we've been grappling with about how you balance having clear and objective safety standards versus trying to maximize the safety possible for any given ADS system that you have to test. And this is the first question is just asking you to give a snap judgment almost about that. The second two questions are then drilling into a little bit more detail. And these are a couple of other topics that perhaps aren't fully covered comprehensively by the Highway Code, but you may still want to assess an automated vehicle against. So how would you assess the safety margins that a CAV should operate with, headways, gaps when it's passing vehicles or obstacles, those kinds of issues? And to what extent should you incorporate social conventions into a CAV's behaviour. And then if you do incorporate those social conventions, to some extent, if you're assessing against them, you're informally including them into a highway code. Okay, so I think I'll give another minute or so for people to vote on that, and then we can put up the polls. And as I say, these are not committing people to any answers, and we're not going to be. We're just using these as a small representative sample of people's immediate feelings, which we anticipate may change following discussions and having time to reflect on some of the issues we've presented. Right. Can we show the results up, and we'll see what the polling is looking like at the moment? Okay, we're just getting quite a few people have had time to reflect and are punching in their votes at the moment, in fact. And just to address, I'll just address one quick question that's come up in the meantime. Will the assessment consider evaluation following type approval, which would be in-use monitoring? And the answer is we've deliberately removed that from the scope for this project because we have a very large scope to cover within the space of a one-year project. But we definitely appreciate that this is going to be critical for the wider picture, and other projects and initiatives within CAV PASS will be addressing in-use monitoring and those kinds of questions. Okay, so we've got some interesting results coming up. Quite a clear vote in favour of the objective standards for that first question, and very much more split answers for the next two questions. Yeah, on question 3 there, it's almost a perfectly even split between the 3 options, which is interesting and showing the controversial perhaps, or yeah. So that's most of the attendees have voted, if not quite everyone. But we certainly welcome further feedback from everybody in the group meetings that we plan to run. As I say, in the next few days following this webinar. Okay, so now I think I will move on. And next up, I'd like to introduce Siddhartha Kastigir from the University of Warwick, from the WMG group there.
Hi, everybody. Good afternoon. First of all, a big thank you to Zain and the team for the invitation to present at this forum. And a good afternoon to everybody on the other end of the call listening to us. I'm going to talk very briefly around scenarios, and that's what Zain asked me to talk about. But I would like to bring in a concept of operational design domain and a confusing but a very important relationship between scenarios and an operational design domain. And at the end of the presentation, there's a key message I would like you all to take away from this presentation. So I'm Siddhartha Kastigir from WMG at University of Warwick, and I lead the verification and validation research at WMG. So here's a brief agenda for the talk. I'll start off with operational design domain and some of the concepts around operational design domain. I'll go into scenario generation. I'll introduce a new concept which we believe is crucial to remove a lot of the confusion around ODDs and scenarios. And I'll talk a bit around how these 3 concepts of ODDs, scenarios, and operational design conditions, ODC, are related to each other. And then I'll finish with a summary. So operational design domain, a lot of you on the call, I've seen the attendees are fairly familiar with the term operational design domain, but I'll like to highlight 2 words in the definition of operational design domain that's from the SAJ 3016-2018 version. So the first 2 words are the key in this definition. Operating conditions is what an operational design domain is essentially. So if anybody ever says that you've got all other kind of attributes of an operational design domain, I would ask you to just guide them back to the first 2 words of the definition. It is essentially an operating condition. And I'll keep coming back to operating conditions whenever I talk to about operational design domain. So the question is, why should we be talking about ODDs? And why is it so important when it comes to scenarios itself? Now, there's a lot of publicity and media traction around the number of miles concept, that 11 billion miles need to be driven. Depending upon how you actually interpret the report from RAND Corporation, you might come up with different numbers. Some say 265 million, some say 7.5 billion. Essentially what we're saying is there's a lot of miles to be driven. But of late, in the last year or so, there's been a shift from number of miles to the type of scenarios. And that's actually absolutely the right shift to be happening, because number of miles is by no means a right metric for safety. But we shouldn't be stopping there. And I think that's where my talk is pitching. Talking about scenario-based testing is not good enough, because you need to take it the next level, because it's about the types of scenarios also. So for example, if you're going to deploy a CAV in central London, that would be very different from deploying a CAV in, let's say, one of the wide streets in Arizona. So the type of scenarios that you're going to experience in central London are very different to what you would expect in Arizona. So just the number of scenarios is not important. It's also the type of scenarios that needs to be focused on. And that's one of the reasons why ODD becomes so important, because depending upon your operating conditions, again, I'll go back to the first 2 words, depending upon your operating condition, your scenarios would change. And this is highlighted even so more when you talk about the same system being put in 2 different operating conditions. So here's a system developed by Origo, one of UK's flag bearer when it comes to autonomous vehicle technology. They have a low-speed shuttle that's being deployed in city centers, and you have a low-speed shuttle that's being deployed on the air side of an airport. Now, the technology on the 2 systems are almost the same, but the kind of scenarios that they're going to experience is very different. And that's actually a function, again, of the operating conditions and the operational design domain, which essentially is the operational design domain. So that's one of the key reasons why ODD becomes so important. So what is an ODD? Now, we've spoken a lot about why is ODD so important, and we need to now talk a bit around what is an ODD. So as part of CCAF funded work at BSI, we've been very fortunate to be one of the first nations to carry out some work around trying to answer this question of what is an ODD. So as part of BSI's PAS 1883, which is soon to be published, we've come up with a taxonomy of what are the different attributes that you would use to define your operational design domain. Essentially, you would see that each of these attributes that you see in front of you is an operating condition of a CAV. So sceneries are essentially all these geostationary objects in the operating conditions. Environment, as the name says, is more around the weather and the atmospheric conditions, and dynamic elements are all the dynamic entities that would be in your operating condition. Now, before I go into the relationship between ODDs and scenarios and ODC, let's talk a bit around scenarios, because you can't make that link if you don't know what each of them is. So we've been quite fortunate at WMG to be part of a fantastic project, CCAF funded project called OmniCAF. And as part of this project, we've come up with a hybrid methodology of creating scenarios. So we have accident databases that we analyze to understand what are the causes of accidents. We analyze real world data from insurance providers. So we are very fortunate to be partnering with Admiral, who are one of the partners on the OmniCav consortium. And we analyzed the insurance claim records to identify what are the attributes which cause near misses and insurance claims. And thirdly, which is what I would call as a knowledge-based method, we use an approach called as STPA, which is essentially a hazard identification method that we use to identify potential causes of failures. Now, the first two, you might call them as data-driven approach or database methods of scenario generation. And the third, you might say, is a knowledge-based method of scenario generation. At the end of the day, all these three methods is what they're doing is giving you a set of scenarios. You can have a fourth way, a fifth way, or a sixth way. Essentially, all types of scenario generation methods will give you a set of scenarios. And that would go into what we call as the UK's National CAV Test Scenario Database that we're developing. And it might have a scenario description language, and it might have a few parameters underneath it. But that's not the focus of this presentation. The focus of this presentation is, depending upon what type of scenario generation methods you might use, you will end up with a scenario database. And every organization might have their own databases. So a manufacturer A might have their own database, a regulator B might have their own database, a tier 1 supplier C might have their own database. At the end of the day, you have thousands of scenarios that you have in your databases. Now, just having those thousands of scenarios is not good enough, because again, that link to the operating conditions, the link to your ODD and the mapping to your ODD is important. So here's 3 examples I'd like to talk about. So let's assume you've got 3 different ODDs or 3 different operating conditions. So let's take the first example where you're more or less city center kind of environment, where if you try and define that operating condition using BSI's ODD taxonomy, you will end up saying that you've got a traffic attribute with pedestrians, cyclists, and passenger cars, and you've got shared pathways in the zones. So essentially what you're saying is, these are the attributes that characterize your operating condition in which you will deploy your CAV. So your scenarios need to be a function of these attributes. So essentially, you need to query your scenario database with these attributes to get the corresponding scenarios that you would use for the test, for your test purposes. So just saying we've got thousands of scenarios in this huge database and we want to test all the scenarios for your CAV is a bit naive to begin with, and also inefficient. So, and the reason for that is, if you take the second example here, if you're deploying a motorway chauffeur system, and you've got very different attributes. You're talking about a divided four lane highway on sunny weather and daytime conditions. Those are very different when it comes to the other one that we just spoke about. So again, you use these attributes and query the database to get the corresponding scenarios that you need to use to test your motorway chauffeur system. And similarly, if you take the other last example over here, if you, again, using the same taxonomy from BSI PAS 1883, we're saying we've got snow, we've got undivided drivable area, you query the database, you get the corresponding answers, corresponding scenarios. So this stage is something that we're not doing enough of in the CAV development process, or we're not talking enough of. Maybe we subconsciously know that this is something we have to do, but we're not actually explicitly saying that, because we only talk about, oh, we need lots of scenarios, oh, we need different types of scenario generation methods. But linking it to the ODD is the key piece that's missing, has been missing in the jigsaw. So when you start making these links, then it gives rise to a lot of good things, but also some not so good things. And that not so good things is about this confusion between what is an ODD and what is a scenario. And I've been quite fortunate to be speaking with lots of people, both nationally and internationally, and even had the good fortune of talking to people who actually coined the term ODD back in 2014, the people who wrote J3016 at that time. And here what I would like to do is try and clear some of this confusion through a few slides. So let's take this example where we've got a T-junction and we've got a set drivable area, which is 2 roads, and it's single lane. So if you use the past 1883 taxonomy to try and characterize what you see in front of you, you would say it's a single lane divided road or drivable area, and it's got T-junctions. So these 3 attributes is what you would call is part of your ODD definition, is part of your operating condition. You could add a bit more complexity to say, oh, I can do T-junctions, I can do single lane divided roads, I can also handle vehicles on that roads. It's not surprising, but you are explicitly saying that. So again, using the taxonomy, what we are saying is passenger cars on a single lane divided road with T-junctions is something I can handle safely. So this essentially is your ODD definition. Very narrow definition, I must admit, but is an ODD definition. So what becomes a scenario? Now, when you try and add the behavior of these different vehicles, like the ego vehicle or the V1 that you see here, that's when it becomes a scenario. So you're adding the behavior of the entities that is part of your, that is part of the scenario, that it adds the level of detail that is required to classify it as a scenario. So for example, if you consider what the text in front of you, don't worry about the syntax or semantics of it, just forget about that. What I want you to focus here is we are defining the behavior of V1, which is drive towards, it's turn right and cut in, turn right and cut out, drive away. It is defining the behavior of the entity in your ODD, which makes it a scenario. So now this syntax and semantics is the scenario definition language that we've developed at WMG, but that's not important over here. What is important is the bit in the middle is the scenario definition, part of the scenario definition. The bit on the left is your ODD definitions. They are distinct, but they are related. And that's the key message I would like you to take across today is scenarios are not the same as ODDs, but they are very much related, and scenarios need to be a function of your ODD. So the question we have now is, we've got this confusion. Why was this confusion created? And what are we doing to remove this confusion? And that's where we've introduced this terminology called as operational design conditions, ODC. ODC essentially it combines 3 aspects. One is the operational design domain itself, in which we talk about the operating conditions. The other attribute of ODC includes subject vehicle capabilities. So things like your vehicle can do a unprotected left turn on a sunny day, but it cannot do unprotected left turn on a rainy day. Now that's actually a subject vehicle capability. It's not part of your ODD because you could do, it's actually the result of the ADS to an operating condition, this subject vehicle capability. So it's not part of the ODD, but it is an important feature that needs to be considered somewhere in this whole safety concept. So that's where ODC becomes very important. And the third thing here is something that we keep forgetting. Now, when you talk about level 1, level 2, level 3, even sometimes level 4 systems, things like motorway chauffeur, human driver will always be part of your complete system safety argument. You cannot just make your system safety argument considering the ODD and the ADS itself. It's also the safe use, because a concept that we keep pushing at WMG is safe deployment does not just mean safe technology. It means safe technology plus safe use of that technology. When you combine these two together, only then you will have safe deployment. So these 3 attributes together are key to a safe system definition. And that's why the concept of ODC becomes very important. ODD has been talked about a lot, and rightly so, but we need to start focusing from an ODC perspective also if we're really serious about things like ALKS and some of the other level 3 systems or that are touching the higher levels of automation. So there are lots of terms I introduced, and that's one of the reasons why we need standardization, so that we all speak the same language. There's an absolute need for common understanding across this spectrum, but it's a crowded landscape. Each and every standardization body nationally and internationally wants a piece of this pie. Some of the non-traditional standardization bodies have also jumped onto the bandwagon, which is absolutely brilliant, actually, that there's so much interest in standardization. And I've listed some of them over here. In the UK, we are quite fortunate that BSI is playing not only a prominent role nationally, but also internationally. One key thing that we need to ensure across all these activities is we should not be creating standards that conflict each other, because that will only add to the confusion that is already a very confused industry. So standards have a key role, but even more important, national standardization bodies like BSI and ISO at the international level have a big part in coordinating all these activities so that we ensure that it's not being duplicated, but more importantly, we are not doing contradictory things. So what I would absolutely not want is two of these organizations creating the standard for the same thing, which do not match each other. So I think that's one place where CertiCav and UK, BSI and CCAV can play a key role internationally to bring everything together. So just very briefly on the BSI work that we've been doing in the UK, we've been very fortunate that it's got a lot of interest in the UK, and we've got a diverse set of members on the steering committee, both from a manufacturing perspective, but also from an end user perspective, and even the likes of infrastructure providers like the Met Office and Ordnance Survey. And it would be published very soon. It's going through the last set of what you call the design work, and it will be published in, I think, first week of August. It will be freely available. Absolutely recommend you to download a free version of the document and read through it. And please come back to either CCAV, BSI, or to myself if you would like to discuss that more. We're also using the document as a basis for the ISO version, that is ISO 34503. So in summary, what I would like to say is one of the things that actually Duncan mentioned, that it's the higher levels of automation that would give us the benefit of this technology. And safety becomes paramount when you start talking about those things. And it's great to see that all these countries are talking about safety. And ODD and ODC definitions are key to ensuring safety in this world. But it's important that we understand what these terms actually are and not confuse them with scenarios. So they are important terms, they are related terms, but they're not the same. And one key message at the end, no single organization, be it a research organization or a manufacturer, or no single nation on its own can crack this problem of CAV safety or challenge of CAV safety. So collaboration and data sharing, both nationally and internationally, is key for us to ensuring that we reach the utopian dream of higher levels of automation. And that's it from my side. Happy to take questions later on, and or you can drop me an email also. And I'll hand over to Zain.
Yes, thank you very much for that, Siddhartha. I fully agree that we need better terms than just ODD, and thank you for your efforts in trying to clarify confusion in the community there. Okay, so my slot is following on from Rob and Tom, who spoke about how you set the safety criteria and fundamentally how you can then assess an autonomous vehicle against that criteria. I'm going to go to the next step, which is when you look at a regulatory or local authority-based assurance process, how do you do the independent assurance of a system against the safety criteria that have been set out. And I think this is very relevant because the public really do care about the safety of cabs. I've got some very recent news articles here. Certainly whenever there's an incident involving a semi-autonomous or a prototype vehicle, that tends to get widely reported in the mainstream media. And I think the public have a real expectation that authorities will make sure that only safe autonomous vehicles are provided to them as a service or for direct sale ultimately. Especially, I'd say especially in the UK. So some other countries have a culture of leaving this more to the developers and the manufacturers themselves, but in the UK and Europe, we have a strong culture that we perform this independent assurance of the safety of products. And it's not just the public. The Law Commission published an excellent 2 consultations on autonomous vehicles aimed at stakeholders within the industry. And in their first consultation, they posed a similar question. And the quote is, a large majority of respondents thought that a new scheme was needed to ensure the safety, increase public confidence, and fill the gaps in current type approval processes. I think this is particularly the case for cabs because there are a lot of new entrants developing new technologies and not coming from an automotive manufacturing background, but coming much more from an AI and software background. And for those organizations, perhaps the incentives and the risk appetite are different. Even looking at the major manufacturers, there's been some erosion of trust following things like Dieselgate. And if we look at Boeing, particularly the 737 MAX incidents, I've got a quote about the role of the FAA, which is that they pretend to inspect and Boeing pretends to be inspected when in fact Boeing is doing it almost entirely by itself. And we want to avoid that. We don't want to have any, we want to ensure that we have independent validation of safety in the autonomous vehicle world. So what's our aim? It's to maximize safety, but perhaps more specifically, we want to maximize the confidence we have that the system we're testing meets the safety standards and criteria that have been defined for it. And this is a difficult problem, partly because we have limited time and resources available to assess any particular system. Also because assessing to confirm a high degree of safety requires information to be shared by the ADSEs. But conversely, we don't want to restrict the technology or innovation that the ADSEs are allowed to produce. Restricting innovation in the long term may well have the opposite result. It may well decrease the overall safety of the systems we end up with. So I think within the international communities and in particular within the UNECE groups, there's a definite feeling that we need several pillars for this independent assurance framework. And audit is the first pillar is going to be quite critical, looking at, in particular, the safety case that the ADSE has developed and the processes they followed to ensure they stick to that, perhaps looking at, for example, training data for machine learning systems. Scenarios are very likely to be critical because they define the conditions and circumstances under which an ADS is expected to perform correctly. And this may go down to, for example, an audit of how the ADSE has developed its own internal test scenarios. Simulation and Hill hardware-in-the-loop are very likely to play a large role given the coverage challenges. Physical tests, again, vital pillar, both controls tests on proving grounds and very likely unrestricted tests on public roads. We think that examining performance within trials on public roads is a very good mechanism also to acquire more confidence in the safety of the system. And then, as I mentioned earlier, in-use monitoring is a key aspect, but that's out of scope for our discussions on this project. And I just wanted to give some illustrations on the complexity of the test space. And really this is because an ADS has to handle the entire dynamic driving task. And this means that as a system, it has an input space that's far too large and complicated to test using traditional methods, in particular that have been used in the automotive industry, such as ISO 26262 and the V-cycle. To highlight, these are of course still needed, still very important, but not sufficient by themselves. 26262, for example, considers random hardware failures as a major issue to have the risks mitigated, whereas when you're assessing an ADS, random hardware failures is quite low down on the things that you worry about. There's far more complicated decisions and aspects that need to be confirmed as safe. And of course, you don't have a human driver available to mitigate the failures. For CertiCAV, we're looking at level 4 and above. So we're assuming there's no fallback. What you're really concerned with is spec errors and complex interactions between complex systems. And to try and give an example of how hard it is to define a spec, I've got this level crossings case. So how would you write the spec for an autonomous vehicle approaching this level crossing with the barriers down? Does your specification explicitly have to detail what to do when there's already a queue of vehicles waiting at the barrier? Does it have to say what happens if there's a lorry at the front of the queue and you can't see the whole of the barriers? What happens if there's a car parked halfway onto the road, 3 car lengths in front of the barriers? What if it's dusk? What if it's dusk and there's a grey car at the back of the queue? What if the lights aren't working but the barriers are still down? There's an almost unlimited number of scenarios that you have to consider. And the other side of this complexity is that we have quite a lot of organizations with different responsibilities involved in the ecosystem. We've tried to create this diagram to help our understanding of the roles and responsibilities. So it has some impacts on what we do and how we frame the rest of the CertiCAV framework, but I think I won't dwell on this right now. So what do we need for the independent assurance part? We definitely need an audit, but I'll note that an audit is indirect evidence of how a CAV behaves. You can confirm that the ADSE has followed all the right processes, is conforming to the standards, but that's not quite the same as testing that the CAV itself behaves correctly. And that link is slightly more tenuous when you have complex software-based systems. For more traditional hardware systems, following standards and processes is a very strong guarantee that the end products will be safe and compliant. But with the complex software systems, I think this is a much less strong link. Physical tests, however, are the gold standard. If you test a CAV on the road, that's how it's really going to behave on the road. And perhaps public roads is the best option, but there are advantages and practicalities that mean private facilities such as proving grounds will have to be used quite a lot. And the problem is just the test space, the size of the test space. So I've got some back of the envelope calculations here. Trying to start with NHTSA and Waymo have a set of 47, not even really scenarios, they're behavioral competencies. They're a little bit too abstract to really even be a scenario. But if you take those, if you supplement them with say 100 edge cases and 100 examples from accident databases to get a total of 250, you're still testing a very, very limited set of scenarios, set of the driving space. And then for each of those 250, you test them in the 3 fundamental use cases of highway, urban, and rural. And then you run 5 fuzzed variants with slightly different positions or speeds or participants. Multiply all that together, you get a total of about 3,700 scenarios. And that's scenario tests. That's really, again, for a very low level of assurance. Again, I'm saying that we can have a crew of about 5 people running tests and 2 days to run a total tests of five scenarios. Then you get about 7,400 person days. And for comparison, the UK's certification agency, the VCA, has a staff of about 60 people working on approval. So they could test, if they used all of those staff, not quite 2 vehicles, 2 ADSs a year. And clearly those staff are already busy doing other things at the moment and aren't available just to be pulled onto ADS testing. So this really illustrates that we can't get enough safety from physical tests. We need to do simulation tests. But if the ADSE is doing all of the simulation tests, can we audit and assure ourselves that they've been done correctly and sufficiently? And this is very hard for simulation, but for several reasons. But partly because a lot of tool chains are proprietary, so you can't go to a different organization and ask them to reproduce the results. Even if you imagine the tool chain itself is certified, it's hard to have absolute assurance that the evidence presented by the ADSE was directly generated using this tool chain. And you really, it's to some extent, it's a numbers game. If you have 1 million or more scenario results, you can't audit these at the level of detail needed. One thing that will help a lot here is verification by physical recreation of a random subset of the scenario runs. Issues here are the statistical significance is going to be quite low because you can only again test a handful of scenarios physically. And the ones that you can test physically won't cover the whole space of scenarios that need to be tested due to limited physical road layouts, what the weather happens to be, risk criteria. So again, for the project's advisory group, we posed this question and there was a split vote. Everybody thought that simulation testing was vital. It was exactly equal numbers who felt that simulation testing should be performed independently by a third party versus the ones who felt simulation testing should be performed in-house by the ADSE. So we have a longer term view that independent simulation testing is probably the way to go. During the music projects, we developed this framework to illustrate how it might work. As you can see, the regulatory body on the left here is setting the safety standards and choosing the scenarios. On the right, the ADSE is providing the ODD of the system being tested and access to the ADS itself. And there's an independent organization, hopefully using our scenario library system Music, that can perform these simulation tests. And just quickly to cover some of the interfaces that you have to define to make that feasible. You need to do a simulation test, you need an input scenario, you need the physics-based 3D simulator, such as the open source system Carla. You need sensor models for all of the sensors on the vehicle that you're testing, and they translate positions and objects into sensor data as seen by the more decision-making parts of the ADS. Perception processing and decision-making, I should say. The ADS is the system under test, but it also relies on the dynamics model of the vehicle to feedback updated positions into the simulator. And we feel if you standardize some of the interfaces and definitions of these 3 components, you have a very good chance of making a robust system whereby an ADS to be tested can be plugged into the rest of the system. So as I say, this requires a standard format for vehicle dynamics, which you then verify independently. Standard ADS interfaces, which OSI under SAM is now working on. The most complicated part of this perhaps is a standard format for perception system models. And I think it's going to be quite hard for simulation tools to simulate physics realistic sensors in enough fidelity and transferability to be appropriate. But you can You can have a higher level model of a perception system that does account for line of sight, that has statistical properties that map correctly to the real world, such as the number of false positives and negatives. Again, such a model would have to be independently verified. And then finally, you need to interface to the ADS behind the sensors in order to insert the outputs of this perception system model. So that's more of a long-term view. And then building from that, we can also define a plan for nearer-term approvals of vehicles. And having this longer-term goal in mind means that we can build our framework now, evolve it in the future, and know that it's going to be robust against these future requirements. So in this nearer-term plan, we have a core set of behavior scenarios, and you will audit the ADSE. The ADSE will run and test these scenarios in-house, but you audit those. We'll have some validation of the simulation environment, perhaps by certification of tools, or possibly the most straightforward way to correlate against physical tests. We'll have some focused sets of physical tests. And then I think to achieve the necessary confidence in the safety of systems, we probably also need a separate test for the perception systems, which requires accesses to the object model of the ADS, a set of perception scenarios with, for example, perception targets, and a standardized way of carrying out those tests. So those are our two early ideas. I should say that this is what we're going to focus on next on CertiCav. So these are very exploratory ideas, and we are really open to feedback, and now is the time. And so hopefully in the group meetings to follow on, we'll get to hear some of your opinions. However, right now I do have a quick poll to get. Again, we want to get some snap views on some of the areas that we presented. So the first question here is addressing the topic of the complexity of independent validation versus the confidence you gain in the safety of the system. So we've reversed this question. We're saying, what things do you think an independent assurance should not cover, because it's perhaps reducing the ability to have a unique offering from the ADSE, or it's an unrealistic amount of effort is involved. And then question 2 is, what kind of information should the ADSE share to enable this verification, independent verification? And question 3 is kind of to mostly a talking point for the group discussions to follow. If we were going to verify, for example, the simulation of 1 million test runs, what sample size should we verify independently to have confidence in those 1 million test runs? And clearly we have a range of options here between doing 0 and doing all 1 million tests, repeating them independently. And somewhere in that spectrum, we're going to go beyond what's feasible for physical tests and move into necessitating independent simulation tests. Okay, so I will give everyone a couple of minutes quickly to vote on those. And we are starting to get questions coming in as well. Yeah, just to note for question 2 on information sharing, we're not intending to define everything in our list. We're just highlighting some of the more unusual suggestions to get votes on those. We're quite aware that safety cases and other aspects are definitely going to have to be shared by the ADSE to enable any audit or certification processes. Okay, we've got a few votes. Okay, do you want to flash up the results so far, maybe? And oh yeah, we're getting a few more people are voting now. Okay, I think got a reasonable number of votes now. Okay, so the results are very split, but a few interesting ones where there's a little bit of a consensus, such that catching edge cases that the ADSE has missed is not seen as something that is the role of independent verification to do. And again, a spread of results on this sample size suggestion for my 1 million scenario tests. Okay, and also finally, just to note, there was a question. The slides will be available to everybody afterwards, and we will also try and publish these poll results. We will certainly be presenting them at the start of the group meetings later. Okay, I should hand on to Richard. To talk about next steps and Q&A.
Okay, thank you, Zane. I hope you've all found these presentations interesting. I hope you've all enjoyed taking part in the polls today. So next steps, these small group sessions. As part of the registration, you're asked to sign up to some follow-up small group sessions. You may have selected several of those. If you did, you'll only be, you'll be allocated to only one. We want to try and balance the number of participants across each session sort of fairly even if we can. Each of the sessions will be chaired and facilitated by a member of the CertiCAB project team, and we'll explore your thoughts in more depth on these three main topics which we presented and polled you on today. So the safety criteria, scenario validation methods, and independent verification. Invitations to these sessions, along with details of how to access them, will be sent by the chair for each session, either later this afternoon or probably more likely tomorrow morning. It's quite possible, understand, your availability may have changed since registration. If it has, don't worry. I'm sure we can schedule you onto an alternative. And if that's the case, please just let us know by rejecting the meeting invitation that you do receive with a remark which indicates your new preference or preferences. We'll make sure that the full schedule of sessions will be attached to those meeting notices. Okay, so so that's that. So again, once again, thanks to all of our presenters. There have been some questions come in. We'll now try to answer some of those from the Q&A window. And as I said before, any that we're not able to or that we don't get around to answering today, we'll endeavour to do that through the small group sessions, or alternatively, we'll follow up with some written responses later. So I'm going to read through these. I'm going to try and allocate them to one or more of the panel. So the first question is, do you anticipate that the traffic scenarios held within a database is the minimum which OEMs need to demonstrate compliance against, or are OEMs expected to use their own scenarios to support the assessment? So I don't know, Siddhartha, maybe do you want to take a start on this?
Yeah, okay, I'll have a go. Thanks, Richard, and thanks, Banavi, for the question. interesting question. I think it's two parts to that question. There's two parts to the question. One is the minimum set that I would say would be part of the regulatory scenarios, which has to be a function of the ODD, as you might have noticed from my presentation. But the other part, rather than saying that there's OEM's database of scenarios, which they may not want to open up to the independent tester, it would be more around the process of generation of the scenarios. So I would say there would be minimum set that you absolutely need to do as a function of ODD. And the second bit would be how you are generating the scenarios and the types of mechanisms that you're using. I think that might be the two pronged approach that you might want to take. Happy if somebody else has some other opinions about this. Might be worth seeing if Duncan has an opinion about it.
Thank you, Siddhartha. Yeah, what can I say? I mean, I think in use of OEM's own scenarios, the expectation, of course, would be that they would have developed against those, and therefore, as a regulator, we wouldn't expect to learn much from that. So I think the focus is really on how we create a regulatory database of scenarios that we can use, which OEMs potentially have access to assist their development, but during a sort of approval assessment, that they wouldn't know which scenarios would be selected, and those scenarios would be regulatory scenarios rather than the OEM's own ones. Thank you.
Okay, thanks, Duncan. And that, I guess there's another question that leads on quite nicely from that, which I think I'll ask next from Brian Smith. So thanks, Brian. So there's been 3 scenario databases mentioned so far today, and these are just the ones this panel is involved in. Do you feel something can or should be done to build a comprehensive industry-wide database of scenarios? I might say a word on that first, and then I'll go to the panel. I think, really good question. I think what's important here is that standardization. So, the database is just a tool for holding the scenarios in. But what's really important is the language and the specifications that are used to describe those databases, and define them, and build up the set of scenarios for sort of use in safety assurance. I think if you've got some basic standards and standard languages for explaining what these databases are and scenarios are and describing them, then whether they're all held in a single database or whether they're held in multiple databases, it's a common set of scenarios. So again, I'd maybe ask Duncan from the view of the regulator as well on this side.
Thanks, Richard. Yeah, I mean, just to step back to history, the whole music project was something that Department for Transport recognized very early on, that scenarios were a critical part of developing automated driving systems and would very likely be a critical part of the assessment of those systems. And so our aim has always been that, or in starting the music project, the multi-user scenario database, for those who don't know the acronym, was always that it should be a common database that's accessible, not just for regulators but for developers, as a common source and facility that can be used, because we're conscious that everyone is having to create scenarios and create ways of assessing against those independently. And so it makes sense to try and commonize where it's possible. But I'm sort of coming at this from a high level and don't know enough about the detail. That's why we need the technical experts to understand how feasible that really is.
Anything, Zane, you'd like to add on that? Or?
Yes, absolutely. So that our intention is that music will fulfill the role of a regulatory central database, and we've tried to be as open as possible. There was a question about access to it. It's online. There's a live beta version that people can go and register at. and try out the scenarios and functionality that we do have at the moment. And it's also been released as open source, which means if anyone wants to run it in-house to help with their own testing and processes, they can do that too. Really, the scenarios themselves is a topic that the regulators are starting to address. For example, at the ALKS regulations, they have a set of test scenarios described at a relatively high level. And I think as that progresses, it'll be clearer how music should be populated. But to note, there are some scenarios in there already to enable people to try out the formats and interface to the system. And we are closely aligned with Open Scenario. We were members of developing the 1.0 Open Scenario spec, and we're also participating in the Open Scenario 2 project that's started fairly recently.
Okay, thank you. Okay, I'll take a question here from Gil. So why, this is probably coming to you, Siddhartha, so just heads up. Why is a scenario a function of ODD? For example, assume a scenario contains 1 or 2 DDTs, which may be generic in nature. These can be performed in many different ODDs. So a possible paradigm is to match a scenario into an ODD and create a test.
Okay, thanks, Richard, and thanks, Gil, for the question. Yes, a scenario is a function of ODD when you come from a regulatory perspective, Gil, because if you are certifying or regulating a particular cab can operate in a local authority or in a particular town or a council, you need to ensure that the characteristics of that area are captured within the scenarios. So yes, what you say is possible, but it's more from a development perspective. I was coming from a regulatory perspective. Hope that answers the question.
Okay, and then finally, anything else to add to that, Zane, from our side?
No, I think I'm happy with that.
Okay. Okay, I'm just conscious of time, and we promised we would finish this on time. I think we've managed to keep to time so far. There's still 6 unanswered questions, so apologies we didn't get around to those, but thank you very much indeed for submitting them. As I said, we'll try and find another way to answer them through either the small group sessions or alternatively, a written response by email at a later date. Okay, so I don't know, Nick, if you could just move on to the last slide for me, please. Okay, so before we close, firstly, thank you ever so much for attending and for your contributions to the polls and the Q&A today. We look forward to talking with you some more during the small group follow-up sessions later. Again, thanks to all the speakers, especially to Duncan and Siddhartha for taking the time out of busy schedules to join us. That is really very much appreciated. Thank you. I'd also like to thank Nick from our events team, who you've not seen or heard today, but he's been working incredibly hard behind the scenes to set this up and run the technology. So thank you, Nick. Good job. And if you want even more, we have an excellent program of webinars at the Connected Places Catapult. So here's just a few that are coming up in the coming days. So the first one I very much like the sound of, Avoiding Carmageddon, post-COVID-19. Connections Cafe, some of you may have been to the previous transport cafes that we had in our previous organisation, guys, and then Understanding and Improving Air Quality later in the month, followed by a data science webinar at the start of August. So all those events can be found on the CPC website under the events section. So please go and have a look if you're interested. And then finally, we'd love to hear how we've done today on the webinar. So please do fill in our survey. Nick posted the link in the chat box. So please click on that and provide your feedback. So on that note, I think we're just about to click over to 4 o'clock. So on behalf of myself, the whole panel, thank you very much for your attendance and goodbye.